So I'm really happy to be here. I've been doing voice over IP software, open source voice over IP software for a really long time, or for me it feels really long time, and mostly I've been doing technology, like working on ZIP Express Media Server and working on the technology itself. But today I want to present something different, which is an application of a couple of technologies, a couple of open source technologies to one project, which is really interesting, and I think it should be really interesting to people here for two reasons. One is that the organization that I've had the chance to work with are really doing really cool things, and the other thing is that it's also a really interesting application of technology, which should be even useful or interesting to many people who are building voice over IP networks. As I said, the organization I was able to work with is Rhizomatica on the left, Seyssel, Altamundi, and TIC AC. What is Rhizomatica? It's an organization. We have a representative here. If you want, can get into touch with Keith. They support communities who need or want to build and maintain self-governed and self-owned telecommunications infrastructure. So they help people to come together and build their own phone network, like real GSM phone network. As you can see here, that's an antenna and a village. And so they are really putting up, or they're helping communities to put up phone masts. And in this beautiful atmosphere here, that's in near Oaxaca in the south of Mexico. And this is communities where they are currently running these open source telephone networks. Here is a bit zoomed in east of Oaxaca, and why is there many? You see here the reason. This is a map of the mobile phone mast BTSs in the area, and you see that here in these mountains there's almost none. Yeah, there's very few, so people don't have coverage. No commercial operator just goes there because commercial operators are driven by money, and there's not so much money to be made. So a different way is that people come together and build their own community networks as alternative to the established commercial ones. So beautiful it can look like. Another partner in this project is Seyssel. They are more research and development company, and they have been operating a phone network in Pearl Lagoon in the south of Nicaragua, or in the east actually of Nicaragua on the Caribbean coast. So how do these community cellular networks, how do they connect to the PSTN? Because if you have these communities, the cellular networks in a village, they can freely talk to each other. But then, and they can also independently of an internet uplink, they can talk to each other. But then if they want to call their relatives or friends in the city, or the people in the city want to call them, then you need some interconnectivity to the PSTN. And if you buy DIDs, phone numbers for everyone, then it's really expensive. Everyone has to pay $2 or $1 per month for the phone number only. And so how does it work normally? You have an uplink to a data center, you have a ZIP trunk, and usually you have one inbound access number, and if someone wants to call, they call this access number, and then they enter the extension in an IVR, and then only then they connect. And they have to pay for this inbound, have to pay to make a call outbound, and SMS isn't possible because they don't have SMS number and there's no SMS peering. Yeah? So as people in the city have internet, or if they have internet, the goal would be to connect directly. To connect, we can use the internet. The data center is already in the internet, so we can connect directly from the cellular network to the users. And I was thinking I can just simply show the app here. So this is the result. It's an first an app that runs on the mobile and on the laptop as well. Here I can see my number, and if we are lucky, it's a little bit dangerous demo now, but just for the fun of it, I type in my number 626, maybe because it, yeah, so calling here, now I'm established and might even have an echo. Yeah? So after the call, here's a, how was the call? It was really excellent. Have a comment. Oops. FOSDEM. Yeah. When you build such an app, the requirements for it, for this application, is it should be really easy to use, so there shouldn't be many options, or people don't, usually users, they don't know what is a zip server and the port, and is that TLS or whatever kind of thing, and NAT and stuff. It should be lightweight, so it also works on old phones, and it should be, if possible, work on smartphones and on the desktop, and if possible, we'd use make an implementation which is accessible, so people can actually join the project. Or you don't need to have years and years of experience in telecoms to join the project. So for a VoIP app, which should work on a smartphone, you could either build a native app or a web app, right? Nowadays, so we're thinking and are still thinking about adapting an existing VoIP app, but then we would also have to maintain one native app, like, for example, CZip Simple for Android, one maybe for iPhone, and how about the desktop then as well? Also, it involves a lot of testing and probably a lot of low-level tech knowledge to be able to build a native app. Yeah? If we build a web app, so we went this way in this project, and we are using web technology for the user interface and WebRTC for the VoIP stack. In this case, we made a progressive web app, which is just, actually it's just like a normal website with JavaScript. Yeah? And if you do some bits to it, you have this add to home screen function with which you can make it look on the phone like a native app or like a normal app. Yeah? And it has some features which make it work well for offline, which is caching, so that it loads immediately. It doesn't have to download all the code. Service workers, for example, to control the cache or for push notifications. And you can obviously use all the other functionality of browsers, like in-browser, database, local storage, and all that. Yeah? We used WebRTC, which is, I think, a really excellent VoIP media stack, like one of the best, or if not the best, open source media stack that you can get, and it's in the browser. It's basically maintained by Mozilla and Google, and it gives you encryption, NAT handling, jitter, buffer management, really good one, echo cancellation, and all that. And we used the excellent JZip library from Jose to make it easy to do interop with the zip service that we have. So the whole system looks like this. We have one gateway, and it acts as registrar for zip, and it also has to handle push notifications, and SMS messages can be sent to the BSC as a message, so with zip simple. In more detail, what we did was we used Camelio and RTP engine. They work very well together to do a really good WebRTC gateway. And the web phone JavaScript app, which is downloaded from a server with a Let's Encrypt cert, talks over WebSockets to the Camelio server, and the media stack talks DTLS SRTP to RTP engine, and on the other side we can talk zip TCP or zip TLS or UDP and unencrypted RTP or other forms of encryption. And we are using actually the Camelio user database as the central database. Yeah? If you install the app, like if you load the app on your smartphone, if you just type in the web page, it makes them sign up to just a script, which is called allocate number, just simple thing. that actually calls camctl to create a user entry in the Camelio database. So as you see, very simple, putting things together so that it works. Push notifications are a bit more involved. At the moment, we have implemented Google GCM. So when the app is sleeping or isn't open, then you need to somehow wake up the app and make the registration to the Camelio so that it can send the call to the from the Camelio. You can send the invite to the app. How that works is first the JavaScript app actually registers its device identifier with the webPush server, and then Camelio uses this, makes in this separate component a call to this webPush server and sends the message to Google, and Google wakes up the phone, and then the phone registers, and you can send the call there. So that's based on Federico's and others' push notification implementation. Then we thought, okay, now we are building this, but it's really quite involved to set up all this back-end stuff. Yeah. So if others want to join the project, it's really difficult for them. So what we thought would be better if you have a Docker containers, and then sorry, oh, you can't hear. So we thought maybe it's better if we do that all as Docker containers, so people can just in one line, or more or less one line, people can install the whole thing and can start adding things to it or fixing things on it. And so the target is to have a complete install with one line, but at the moment it's actually not 100% working. So this way to build a VoIP app. Oops. Sorry. Huh? Okay. So this way to build a VoIP app is a little bit different than what we used to do traditionally. And I think a pure web app has still quite some limitations. So for example, you can't access the phone's phone book. So we are using a separate phone book in the app. Yeah? Or you can also, for example, on my mobile, you can't select which speaker, whether you're on speakerphone or on the normal earphones. Yeah? Also, the push notifications, to be honest, I'm not 100% sure whether it really works all well. Yeah? And maybe in the future we might consider, or someone maybe contributes, a small native wrapper around it with a web view in it, so that we can still use the same technology, but have all the functionalities of a native app. But I find it also interesting to see nowadays how far in reality is this all this web technology in order to build this really relatively complex and relatively involved apps. Yeah? Another challenge is, to be honest, to combine the web and the telco worlds, because in the web worlds it all goes much faster and the development goes much faster, many more versions and all that. And I think a kind of agile development style was quite good, because we actually had to interact between the development of the application, how does this work, and SIP infrastructure backend, basically. But to make a really polished user experience is actually not that easy, I find. So that's one of the things you need, even if the product looks very simple, you need a lot of, there's quite some complex technology behind, and it needs a lot of testing to make it really work well. Yeah? In the future, we want to make it work well for offline deployments. So even though we will probably not need all the SIP gatewaying infrastructure, still we have most of what's necessary, and actually the web application is the biggest development part of it. So we thought we'd use it also for offline deployments. And then what I'd be also interested in is having an alternative to the Google push notifications. Maybe if someone knows how to do that properly without draining the battery, I'd be really interested here. Yeah? And for texting, it's one of the main goals for the Rhizomatica network. The UI development has started, but it's not there yet. Yeah? So I would like to invite you to join this. I think if you're running for example, also if you're running a VoIP network and want a web app to have your users call into the app, then this is a really cool starting point. Or you can just use it and extend it and join the project. And yeah, I put some links here. Have a new mailing list on the bottom, which if you write there, you also reach me. And as I said, the Docker compose of the server, so you can start setting it up yourself. Or you can just write out percel.webph.one. It's the URL for the Percel version, or webphone.rhizomatica.org. Yeah. Maybe have some time for some questions?
We have time left. Yeah, thank you.
Okay.